So I am recording everything that gets heard in the class, so, be careful, Relations versus functions, and the whole idea about functional notation and evaluating. I should get through all of that. They call that day one, but day one stands for like 45 minutes. Because in other schools, we don't go to school for an hour and a half for one period. So I think I gave enough to get going on this day two stuff, I believe, maybe a page or so. But I'm not going to cry if we learn and I don't get as far as I thought, okay? I'm going to tell you the same thing I told the other students yesterday when they were complaining about not being able to do the test. You guys took your test. I don't think none of you complained. You worked hard and stuff. But, yes. I can't hear you. You weren't here for the test? Okay. You're going to want to leave me your name on a piece of paper, and Mr. Mendoza can open it for you today. All right? And I'll tell him to leave it open for, 24 hours, just for you. When you're absent and you know your stuff's on Canvas, unless you are like a zombie at home because you are dead sick, you probably should have still work on your lessons, because almost every teacher is putting everything on Canvas. There's no reason to ever be behind. However, I know things happen, so I'm not a judge. Everybody has their story, and I respect them all, whether or not I agree. And this is where we began this adventure. And I'm going to erase that. It'll let me. There you go. Nice and pretty. And you can see where you're at, because you got, I think that just takes us all the way through here. All the way, right? There you go. And then there's the homework in here. If there's no questions, well, of course, you can't ask me right now, but you can ask me in class. Take care. Over and out. Really important, I'm not here. I'm here to give you all a passing grade. I'll be honest with you. You do your job, not only will you pass, you're going to learn, okay? You may hate me if I stick this year out, if I stick next week out. Whatever happens, you may, have your opinion. But after all my years, I can't tell you how many people a year run into me that I don't remember. And they tell me about, oh my God, Mr. Curry, everything you taught I had to use again in college. And other people were lost, and I wasn't lost because I remembered what you said. Those things I hold on to, because nobody thanks the teacher, really. I mean, teaching is a very thankless job for the most part. But when somebody comes back to you that you don't even, they look as old as you now, he's like, oh, that's an old man. I had them. Like, I probably had some of your parents. I don't know if anybody went home and asked their parents if they ever had a mystery. If they went here from 2000, past 2000, maybe to 2008 or something, something like that, I could have been their teacher. And if they were from Mercedes, I would have had them from 1990 to 99 then, I guess. Oh, no. I was in San Benito for 90 and 91. So it was 92 to the almost 2000. So but I taught middle school in San Benito. In Mercedes, I taught middle school, junior high for 2 years, 3 years. Then I was at the high school. So. Yes, ma'am. All right. Maybe I don't want to put this video online because I just talked about my personal life. Hello. Please put your name on top where it says, and the date, the topic. The topic is basically written on the board over here. And class, this is 1A, of course, right? So let me see. Sometimes I don't always know what the author meant for me to write, but I think he wants me to talk about relations. And a relation, I'm going to put, if I write correctly, a relation is nothing more is a set of points. Another name for points are ordered pairs. So let me just show you what ordered pair is. It's a number first and a number second, x comma y. Doesn't have to be x and y's. It could be a comma b. It could be distance comma v for velocity. How far did you go? Or it could be how long did I go? Distance, if you're doing physics and stuff. So variables can be anything, okay? Examples, let's see. I'm going to put a set of 1, 3, 2, 4, 3, -1. I'll do one more. 1, -1, and then I'll close it off. That's a set of points. That's a relation. That's just a set of points, always. Now, in here, he wants me to show you different versions of this. So, since I'm lazy, I'm going to use the same points. 1, 3, 2, 4, 3, -1. Did I do the 3, -1? Yeah. Oh, did I do the same point twice?
No. You just needed 1 -1.
Oh, it was a 1 -1. I just can't read my own writing. There. Thank you. I appreciate you. 1 -1. So there's a table. Obviously, you know that. That's just a table. I can also use a map. A map, which means they're in a circle. Like this could stand for my x's. 1, 2, 3. And there's another 1. I don't have to write it again. I can if I want to. I don't have to. Because over here, I'm going to go 3, 4, -1. I don't even have to write -1 again. So how is this going to look? I have to map to it. 1 goes with the 3. 2 went with the 4. Well, that's pretty common sense. The 3 went to a -1. And a 1 also goes to the -1. So it goes like that. It crossed all of them to get down there. Okay. So you can see your relation on a table. You can see it on a mapping. And if you wanted to label X and Y's, you can do that. You can also do it on a grid. Now, I made a mistake because I used a couple -1s, but I'll get it in there, okay? Let's see. 1, 3. Make sure I can see it out there. 1 to the right. I'm going to do it in black. 1 to the right, 3 up. 1, 2, 3. There's the ordered pair. 2 to the right, 4 up. 1, 2, 3, 4. 3, -1. 1, 2, 3. I'm going to have to go down the 1, okay? And I'm blinded, so I hope it's good enough. And then I have a 1, -1. So 1, -1 also. So I have 1 over. So there are those 4 points. It doesn't matter how you see it. Each of those are called relations. Now, you already know if I was to ask you a question, is my relation a function? That's not the lesson right now, but if I was to ask you, is my relation a function? Most people would answer no, because why? Yeah, I have 2 1s. So if I was to do the vertical line test, it does. See that? That means it failed the vertical line test. But that wasn't really one of the questions. I was just, showing off. Okay? Told you, domain. Okay. A domain is a set of X values. It doesn't have to be X. It could be any letter. Whatever the first letter is, when you put the points, if it's distance versus velocity, then the D would be the domain. Okay? In Algebra 1, they called it the independent variable, because you can use any x's you want and plug it into a function or plug it into an equation. The equation, the answer, is not independent. It depends on what you plug into it. So that's why we call the y's dependent. But that's not on the test or nothing, I don't think. That was Algebra 1 talk. But it's nice to be reminded of those words, because you have heard those words. You may have not even understood why. You just memorized it. Dependent, independent. Or independent, dependent, whatever one you had. You know, the X is always the independent, then the Y's depend on the X's. So I'm going to do the domain of my example here. The domain is the set of 1, 2, 3. And I don't have to repeat the extras. It's understood. If you wanted to, you can. It doesn't hurt it. It just takes a little more pencil or ink or whatever. And then the range is the next question here. It's the, I'm sure you can guess at it, set of the Y values. And it doesn't have to be Y. It can be whatever that second thing was in that table, the second column, or the second numbers in the ordered pairs. And so my example of the range would be the range equals the set of a 3, 4, and a 1? Negative, thank you. You know, just so that you know why I have trouble seeing things, I didn't know it until like 8 years ago. I had been misdiagnosed wrong. I have Stargardt's disease, and it's in the back of the eye, the macula, and you know, I'm very fortunate. Most people who have Stargardt's disease are legally blind by the time they're 25. Well, heck, I was, you know, much older than that when an expert. I went to a university. My university was Ferris State University. They had a college of optometry there. They misdiagnosed me. They said I had macular degeneration. And even when I went to an expert to go in the Army, they also said the same thing. But then here in Harlingen, at one of the big ophthalmologic places, I put all that information on my thing. I had to go in and get some evaluation. And said, "Who told you you had macular degeneration?" I said, "All the doctors." Said, "Well, all the doctors are wrong. I'll prove it to you." He took pictures of the back of my macula. And believe it or not, this might be why I'm a Christian. On the back of my macula were these Jesus fishes. Jesus fishes on the back of my macula. And so he showed me the pictures. And if you go online, you can find it. It's true. So it affects the vision, and that's why a lot of people are blind. I'm not blind, but I actually do pretty well for having the disease. But anyway, so don't judge me when I can't read your names on the small print. Even with these, they're heavy. If you like reading glasses, these are pretty heavy duty, and I still can't see everything clear. I mean, I can see you, and I can see crazy things on your desk if you were doing something wrong, but I may not be able to always see who I'm talking to, because I may not be able to see the whole face, you know, clear. Someone yells at me down the hall, "Mr. Carey," and they're waving, and I'm like, waving until they get close enough. "Ah, it's you, you know." Yeah, Caleb. I might remember you. Because I didn't remember your name right a second ago, but I'm going to try it, Caleb, because I've seen you enough times, and there's not many people. I mean, you're a pretty outgoing and friendly person, so that's why I should know your name. But I'm also old, so you know. All right. Here's some examples. Here's a set of points. Notice they're in braces. I think these are the same points. No, or they're not. -1, -1. No, I don't see it over here. They're not the same points. But this is another. Oh, he wants us to give the domain and range. Sorry. Okay. So let's quickly do that. No, I think I want you to do it. Let me hear you. Let me have my video record you showing how smart you are. The domain. Let me hear you.
-1, 7, -1.
Beautiful job. I couldn't have done it better myself. Let me hear more people chime in on the range. Yeah. Yeah. Yep. Excellent. I knew you were my best class. I knew it the whole time. Okay. Next one. Now this is harder because you actually kind of have to count. And I already failed counting today, so I'm not going to give it an attempt. Somebody else. Give me those. Let me pick on one person. Raise your hand. Oh, you. Thank you. Give me the domain. 1, 2. Another one? Okay, you can list it again if you wanted to. You don't have to. Negative what? -3. Is there another one? Oh, I think you were counting. Yeah, that's what you were doing, right? I thought you were counting the 1 again because there actually is a 1 comma -3 down here, but you meant this one to be the negative. Where is it? -1, right? Yeah, there is 2 1s, so it's a 2, -1, -3. And the range, somebody else. Make me proud. Somebody else raise a hand. Please.
-4, 5, 2, -3, 0.
Now, I took his word. So you guys sitting there, if there's a mistake, I'm going to make a lot of them. Just raise your hand and tell me that I did something bonehead, which it happens a lot. And I will not be offended. I'm sure this gentleman back there, if he messed up in counting, I'm sure he will not be offended either. But nobody said anything, so I think you're probably correct. Because everybody can't be wrong. Number 3, somebody else. I want the domain. A show of hands, somebody? No? Okay, go ahead.
-2, -1, 0, 1, 2.
He raised his hand because he said, this is probably the easiest one because they're all listed right here. And he would be correct. Take advantage of the win, And the range? Let me hear everybody.
0, 1, 4.
Yeah. 0, 1, 4, he said. And obviously the 4s are repeated. Obviously, what else is no, that's it. Only the 4s are probably repeated. Anything else repeat? Oh, wait. The 1's repeated too, right? You see that? Okay, wonderful. Now, looking at the picture, when I was going over some problems, I don't know if it was Algebra 2 or I don't think it was here because all we've done in here was looking at solving a system of equations. So I don't think it was you, but it was Algebra 2 students. They could not do the domain and range by looking at a picture. They literally thought the domain, when I told them it's the x's, they only gave me this x. They gave me this x, this x, this x. Maybe they could give me this x. Only the ones they could find. It's kind of silly, right? The domain is all the x's. But you have to understand what this picture does. Since there's arrows and it's not going straight down, you have to believe that it's going down and over. Down and over. Even though it's not going over very fast. But it is going over, because if you look at it, look at the distance from here. It's exactly 2. Now it still looks like exactly 2, but if I zoom in, you can see that it's starting to be more than 2. So there is some sort of movement going to the right. It's hard to see though. So in all fairness, you may not understand that that picture really does go down and over forever and ever and ever and ever, because that's what the arrows do. It says whatever pattern you see, continue it. So with that being said, I had to teach them that, I'm trying to erase it. Didn't want to erase it because there it is. If I told you that the domain was all the x's, and that no matter where I go, if I was to go to the function to 1,000, let me draw it out here, 1,000, if I could get way to 1,000, that if I go to 1,000, I literally could keep going down until I find where this finally makes it over here.
It's gonna be to infinity.
It is. Your domain goes to infinity. How about to the left? So the one way you could answer that question would be in a interval notation. This is going to be a problem. I don't want to plug the iPad because it would die. Is to say a parenthesis, negative infinity, all the way to infinity. Parenthesis means that I'm starting at negative infinity, wherever that is, but I can't really get there, so it's a parenthesis. In a minute, I'll show you the bracket. But if you want a really an easy way, you could have done the words all real numbers. And if you want to be mathematical, the symbol for all real numbers is this fancy R.
That's too much.
I know.
Sorry, sir.
It's okay. I like to give you choices. I like the interval notation myself because that's what we use in calculus.
That's a
Okay.
choice, sir. That's torture.
Okay? Now the range.
Same thing?
Is it really?
Yes.
Not really. Because it does go down forever, but it doesn't go up forever. Where does it end?
It's gonna end up being a negative.
Well, it goes down, but what's this up here? That's the highest it goes. It's a height of 6. So we go from lowest to greater. Does it include the 6? Looks like it. I'll use a bracket. 6. I went backwards. I'm sorry. I lied. I did something wrong. Don't throw nothing at me. Parenthesis, negative infinity, all the way up to the 6. Bracket. Again, this is called interval notation. Now, those poor kids in Algebra 2, I reviewed that with them, and this is the answer that they put on the, they had one that went from, like a domain went from -5 all the way to 4. So I would have done this, bracket, -5 to 4. But here's what it had on their test questions. All the x's greater than -5, but less than 4. We don't do that anymore. I mean, this is okay, but I don't think the average person understands this, that x is between -5 and -4, and because the greater side points to the x, we have to, if we read it from right to left, we say x is greater than the -5, and x is less than 4, and because it's including them, we put the greater than or equal. Remember those symbols? No, see, people don't want to know those. But you do have to know them. But I prefer the interval. Okay, moving on. Maybe I talk too much. That's why I don't get everything done. I talk too much.
You're just like me.
You are very talkative. But, so now look at this number 5. The domain, we're going to do interval notation. Left to right. What's the farthest left I can go? Is it a dot or is it a circle? What would it mean if it was a circle? It would be called open. You don't include, it's in the, it would be like this, open, -6. But that's not a circle. That would be like if it was open. But because it's not open, it's closed, I put a bracket. I put a bracket, comma. How far to the right will it go? Infinite.
So the -6 is in.
Wait, why did I say -6? It's not, it wasn't a -6. Did someone tell me that?
No.
I made it up?
Yeah. You guessed.
I did it on purpose. No, I didn't do it on purpose. I was brain damaged. Negative what?
3.
No wonder somebody was questioning it. Sorry, guys. Told you. I'd be a millionaire if I got paid $1 for every time I made a mistake. Parenthesis. Their range.
So why is there a bracket in the parentheses?
Because bracket means it's including the dot. Parenthesis means it would not include the dot because there is no dot. You can never get to infinity.
It would also be infinity. That's crazy.
Say it again.
That's crazy.
It is crazy. Range. Go from the lowest, -4. Would it be a dot? Is it included?
Yeah, so it's bracket.
Bracket.
Bracket
-4 is the lowest. What's the highest?
infinity.
Are you sure?
Yes.
I agree with you. Because this thing obviously is opening up and over, up and over. If you had the time in the paper, up and over, up and over, up and over.
Anything that goes up goes
It keeps going. Never goes down. It's always up and over. That's why the arrow is there. The arrow says follow the pattern. Okay, number 6. This should be hard. Yes. Yes. So I want to caution you on this picture. There is something going on at this imaginary line here. Well, you don't see it. I'm trying to draw it in. I'll draw it darker. There's this line here. That picture is, well, there's some sort of reflection. It's actually a reflection and a rotation. But the thing about it is that function, as it goes up, it's trying to get to that red line, but it never will get it. It can't be 100% vertical. It's constantly getting closer to that line. Do you remember what that's called? A line that a function is trying to reach, but it never will get there. No, that's 2 lines. Starts with letter A.
absolute.
Nope.
Adderall.
No, it's not a drug. No, it's not a bad person. If you had a line that the function is approaching, but it never reaches. If you were to zoom in way, way up there, you would still see the line is next to it somewhere. Even if you'd zoom in and see, oh, it's not touching yet. And you go, I'll go way up, way up, way up, way up. You would still see the line and if you zoomed in and you pinched on it, you would still see that it was not really touching. But it's getting closer forever. It's called an asymptote. Asymptote. It's possible. That's not really on the test right now, but I decided to tell you what that word was. You should have seen it in Algebra 2. Not necessarily in Algebra 1. But Algebra 2, you had to graph rational functions. Rational functions always have asymptotes. Sometimes your asymptote is horizontal. Sometimes something comes out from the sky and it rides the curve. It rides the curve for a long, long, long time, and it never, ever crosses or touches the axis.
Would that still be the same word or?
Still the same word. Except one would be a vertical asymptote, one would be a horizontal asymptote. And it doesn't have to be the axis. It could literally be coming up and doing this. And you have to say, oh, I see what's happening. It's leveling off. When it's leveling off, it means it's never going to touch whatever this line is supposed to be. It'll never touch, but it does get closer and closer. It's kind of like the love story of the beautiful female, intelligent, that the guy is trying to get, and he can never get her. It's kind of a sad story.
So you improvise, adapt, and overcome. You just gotta keep going.
Maybe I lived it. I don't know. All right. So, what's the asymptote have to do with the domain? That x value will never be touched. But all the x values, everywhere else is perfect. So the domain, how far left will it go? So you go negative infinity. How far right will it go? Well, this part does. Unfortunately, there's a jump that it has to make. What value would that jump most likely be if you zoomed in? No. What x value? You're not even looking. Somebody said it out there. 3. 1, 2, 3. Obviously, my asymptote is 3. Yes. So what we do is we literally, why did I put a brace? Brain damage. I got to quit drinking all that milk. Oh, open. Yeah, well, it didn't help me today. Parenthesis, negative infinity, comma, 3, parenthesis. And then what we say, and, the word and. But the symbol for and is U for union. Means the same. And what? Pick back up at 3 on the other side and go all the way to where? Infinity. I told you this was going to be the harder one. And it's okay if you think it's crazy. It's okay.
I think it's useless.
Most things we learn may seem useless until you need it. I've got a whole toolbox that my wife spent $400 on, full of stuff. To this day, I don't even know what half those tools do. So to me, those tools are useless. But if I have my brother-in-law come, man, he'll take my toolbox and he'll hang a door that I have at the house. He built my fence out back. And he used tools that I didn't even know what they were for. So for him, they weren't useless. When you find a purpose for something, then you realize that maybe it wasn't as useless as I thought. Okay? All right. Range. Same idea, guys. Same idea. You know the range looks like it goes down forever and up forever, but there's that horizontal asymptote that we have to jump over. So how far down do I start? It's down. Negative infinity. And where is the asymptote as I go up? Please don't say random numbers. Look. Look at the y value that can't be approached, that will never be touched. Very good. 0. Union, pick back up at 0 and go all the way up to? No. Infinity. Positive infinity means going up or going to the right. Negative infinity means going down forever or to the left forever. All right, one page down. Back. Let me make that smaller. It all started here. course, your period will be different. Your name will be different. The date will be different. There it all is. If you need to pause it, study this page, fix your page, or find an error that I may have. Of course, some of those I made up different numbers for different classes. Move it on. That was one. Next page. All right, now I want to do all of 7, 8, and 9 only because they're all a little different. So number 7, this curve, you have to assume repeats because there's an arrow and we see a pattern happening here. It's going up, do some writing here. It's going up, down, up, down, up, down, up. You have to assume that it's doing the same thing forever and ever and ever. So you tell me, what do you think the domain is? Well, you can't say just infinity.
Negative and positive.
Yeah, you could say that, or you could cheat and say all real numbers. That'd be okay to say. Okay, nice job. How about the range? He's way ahead of me. Does it include those negative 5s and 5s? In other words, are all of these points going as high as a 5? Looks like it. Are all of these points at a negative 5? Looks like it. So would it be okay to put between negative 5 and 5 with brackets? You see that? Seeing is believing. Just because I say it, just because he said it, try to internalize it. Number 8. That's just a line. Yeah, really, right? Who disagrees with him?
I do out of spite.
Out of spite. I want you to do it out of looking at the problem and having a good reason. Is it all real numbers?
Yes, it's for both.
Are you sure about that?
Yes. It's an open relate.
Yeah, it's an open circle. Therefore, whatever x that is, it's not included.
So what I tell you, it's all real numbers.
Now, you could say all real numbers except for,
That one,
which is?
-1.
You could say that. That would have to be marked correct. All real numbers except x equals to a -1. I'm going to just do the interval notation. Negative infinity to the -1, open on both because you can't include either. And I'm going to union it with 1 to infinity. Okay. How about the range? Does go down forever. It does go up forever, but the y value is what?
Except -3.
Okay, so negative infinity, -3, union -3, infinity.
You're speaking crazy, sir.
You should what?
You're speaking crazy.
I know.
I was crazy.
Crazy?
To think I could have just stayed retired and caught up on. I'm watching this new series called Hijack on Apple TV. It's so intense.
It's union what?
Union -3 to infinity.
Okay, so it's just like opposite.
Yes. Yes. No, I never say no.
Dude, I'm
'cause-
going on the wrong one.
All right. That looks weird. That is an absolute value function in terms of the absolute value of y with shifting up. That we'll talk about that later. But anyway, what does the domain look like?
And then down to all real numbers.
Almost. That's half the answer. Because it doesn't go to the right forever.
It's 0. Who told you that?
Yeah, 0. It doesn't go past the 0. Doesn't include the 0. So it would be negative infinity all the way to 0 with a bracket. Guys, if you have a question and you're doing a good job at writing everything down, we're not here just to see. And I know I got somebody sleeping back there. That person's going to be so surprised when they get assigned a seat. But you might want to wake them up so they don't get in trouble. Nobody wants to wake them up. So,
Hey, wake up. Sir. Wake up. Wake up. Wake up.
I don't want to have to assign you up front. Okay? Range. That's interesting.
Okay, it's only negative.
Negative what? Negative infinity? To where?
To 2.
Who's talking? That you? Or that you? Who was it?
That was me.
No, it was over here.
Oh, I said 0.
How far down will it go? How far up will it go? Oh, then that's what she said. One of them. I can't tell who was talking. It actually goes down forever and up forever. It goes up forever. It goes down forever.
Sir, how?
How? The line goes down forever. The line goes up forever. Granted, it goes up and over, down and over, which explains why it does the domain was negative infinity. All right. Okay. Oh, good. He woke up. I hope he gets his notes caught up. Okay. Domain for number 10. What does it look like to you without having to think too hard? Ask yourself, how far left is it going? There is an asymptote.
Okay, how far left is it going?
Yeah. Or how far right is it going?
Oh, wait.
Let's look at it. Does it look like it's approaching a value, or is it still up and over, up and over, up and over?
It's still going up and right.
It is up, so I'm wrong. It doesn't have an asymptote. It does go up and over forever. Just look at right here. Up, over, up, over. So you got to continue that pattern, up and over. Maybe the over is less, but it's still always going to have some over.
So we're still infinity.
Yeah, you're right.
Sir, reality is the way I perceive it.
Okay. I know. That becomes the in thing today. Whatever we envision must be true. We used to call it mental illness,
I don't belong
Another word for that.
but now you're allowed to be in your world. Range. Range. How far up? How far down? I agree with you 150%, if there was such a thing. Negative infinity to infinity. 11.
Okay, that's what
W- I think I agree with that. There is an asymptote happening.
But I can't write anything on that one.
What's that? Oh, what? You think there's an asymptote?
I wrote this on
Oh, maybe I'm wrong.
See, I was right. It's a horizontal.
I'm not crazy.
I am wrong.
I'm not wrong.
Who-
It doesn't go.
Yeah, I'm wrong.
I'm not crazy. Yeah.
What'd you say? Where? Vertical or horizontal?
Horizontal.
Yeah, you're right.
Yeah, baby. Woo.
So who said it first?
He did.
Both of you?
Driver's line, the guy in front said,
Well, Caleb, make a note on your paper. Plus 5 points extra credit. And on the next test or quiz, you have to show me that. Put the date.
What did you say?
There's really a horizontal asymptote. And I don't know why I didn't visualize it. I have an excuse. I'm blind and I'm old.
my excuse is, I don't
So the lowest is not a negative infinity. It is a what? Yeah, and it's still open though. So -5. Thank you, Caleb, and anybody else who was helping. I wasn't even paying attention horizontally. It's a good thing you were here. All right, domain 11, quickly. What's the domain? Does it look like this goes left forever?
Yes.
Does it look like this goes right forever?
Yes.
Does it look like there's any jumping? Where?
Like it's slowly second towards the left.
What's that line look like?
It's 2.
What's it look like? What value though?
That's 2.
It looks like a -1. This thing seems like it's there because it matches up here. -1. So that's tricky, but we'll go with negative infinity, -1, union, -1 to infinity. The range. Are there any jumps or stopping points for up and down?
No.
No. What could we say? What's the easiest way to say it? We can say all real numbers. I'm going to do this, my fancy R. Woo. I just did it. That's pretty fancy.
It's too much work, man. I didn't sign up for this.
I know. Wait a minute. You didn't sign up for it. They put you here. They didn't ask for your permission.
Actually, I could have chose math models.
I could.
Okay.
I chose the class.
You know, I'm going to give you a little bit of advice. When you go to college, they won't even look at math models as anything. If they see a strong grade in pre-cal, it could go a little further as far as where they think you should be placed, especially if your TSI is a decent score. I think if you do well in pre-cal and you actually take advantage of what I give you, you will score. You could take the TSI over again. And you're going to score monstrous on it, man.
Sir, this is America. What happened to my freedom of choice?
You always have it.
Hey, you actually don't have it anymore. You can't say anything in school.
You're not 18
That's
yet.
bad.
This is the America. Sir, this is the
What do you mean? You mean there's some speech is not allowed? I don't know. Domain for number 12.
There's an open and a closed.
There is. So the domain is going to be a restriction. And we're not going forever, are we?
No, it's not all of them.
So what's the x value to the left?
To the left.
Yep. Negative what? Is it open or closed? Open, -4. To where? What's the x value to the right?
It's actually -3.
Oh, it's a -3?
No, it's negative.
-4. 1, 2, 3. It's 4. And the right? A 1. Open or closed? Closed. Wish my thing would reach to the door. Let's see.
You should get a...
All right. So you see how I like that one because it's not the same as the others. It actually had a restricted domain. It actually told you your domain is restricted, even if in reality this parabola went on forever and ever and ever. Even if it really was that picture, they restricted the domain by showing you that picture. Okay. So the range. What's the lowest it can go? Does it include it? -7. What's the highest it can go?
2.
She's got it. Very good. She is smart. Okay. Oh, now it's time to talk about the definition of function that I already gave you a preview for my first example. A function is a special type of relation in which each statement of the, element, each element of the domain is paired with exactly one element in the range. That means the x's are never repeated. It's the simple thing that I said before. The x values are the first value. The independent variable is never repeated. So these are yes or no questions. 13, I'm sorry. Is that a function?
Yes.
Check each of these x's. Are they ever repeated? No. So it is a function. 14.
No.
Y. The negative 9 has this girlfriend. The negative 9 has this girlfriend. And that's not good.
No, sir. I call him a player. He has games.
He's a player.
He's a player. 15 is that guy.
15 is, I look at a negative 7, negative 5. Yes. Because none of the first numbers are repeated. All right. If a vertical line intercepts a relation at more than one point, then the relation is not a function.
Yes, no, yes.
What was he defining? The vertical line test. So I go over here and ask yourself, is there any place where a vertical line would cross more than once? No. So, 17, yes. Uh-oh. That's bad. How about 18?
No.
No, because it looks like it, except this asymptote saves it. Right? So the answers are, yes, it's a function. No, it's not. Yes, it is. Whew. Wow. What a lot of work. Started way. We had this set of notes. Again, you can pause it, finish your paperwork. Next page. What time's the bell ring? All right. Let's finish as much as we can. Disregard the homework that I said, unless you want to get ahead. Okay? But you can just work on your canvas that he put. Yeah, the third page. I'll be very, very, very proud of you. All right. Explicit functions. You probably never heard the word explicit function versus implicit. Matter of fact, 10 years ago, you only heard those words in calculus. But now it became part of the modern curriculum. So let me show you what it means, or let me define it. Explicit means an equation. I don't like green. An equation solved for one variable. This is the one that you kind of like. Here's an example. Y equals to 3x plus 2. You notice how it's solved for y? That's called the slope-intercept form of a line. Yes, no, slope, intercept, y-intercept. Here's another one. Distance equals rate times time. That's explicit. It's solved for a variable. Yeah, those are, oh yeah. Yeah, it's the example, it's okay. Another one, let's see. I'm thinking here. X equals to the absolute value of y minus 1. That also is explicit because it's solved for x. The y has junk with it. It's not solved for y.
So it's implicit like true.
Oh, I wrote those in the wrong place completely. That's what he was telling me. Okay, I'm going to write it up here. I'm sorry. Y equals 3x plus 2. D equals RT. Boy, I feel so silly. X equals absolute value of y minus 3. All right. Golly, I'm so embarrassed. All right. Now, implicit. The definition of implicit is an equation not solved for one variable. One variable. Examples of that, you've seen this before. 2x plus 3y equals to 10. That's a linear equation called the standard form of a line. That should ring a bell. Standard form, it can be turned into slope-intercept form, and a lot of times that's what we make you do, because calculators graph in explicit mode. I think if you're good with the Inspire, I think there's a way to graph implicitly, I mean. Another one could be x times y equals to 3. It's not solved. It's easy to solve it for x. It's easy to solve for y. Okay? Now, next set. Examples. Write each equation explicitly in terms of y. And then state whether it's a function. What they're saying to you in English, I wish they'd have said just solve for y. We do that a lot. In every class, every math class, we're solving for y. So here goes. I'm going to do it with you. I don't think I need to hold your hand for it, but if by chance I lost you, I will not be offended. How much time we got? We got about 8 minutes. Can we quit playing the musical instrument? I kind of thought you would get tired, but you haven't. To get y by itself, right here, I want to get this y by itself. I got to get rid of everything around it. And it's easier to get rid of a plus x that's on the left side. So I'm going to go minus x. That leaves me a negative 4y is 20 minus x. Got one more step to do. Get rid of the negative 4 being multiplied by y. I will divide by negative 4. I will divide, that didn't come out right. Divide that by a negative 4. Divide that by a negative 4. That cancels out. Y is equal to what kind of 5? Negative 5. And a minus become a, that minus and that minus become a plus. And that's a 4 in the bottom. You are more than welcome to say 1/4 x if you want. Or, okay. Or you can say plus x divided by 4 is just as good.
I like your funny words, Magic Man.
I'm trying to figure who that guy is. I'd like to meet him. Number 2, by the way, that one was just a linear equation. Number 2, in case you don't know, is actually the equation of a circle with a radius of 5 and the center being at 0, 0. Hopefully we get to talk about that, but to solve this for y, I need to move everything over that is not a y. That would be get rid of the x squared. So I will subtract x squared from both sides. That cancels it. That leaves a y squared equals to 25 minus x squared. Some people think I'm done, but I'm not, because that's not a y. How? No. Square root both sides. And when you do square root both sides, you're supposed to remember that there's 2 answers, because plus or minus of the answer. For those that don't believe me, if I ask you for the square root of 4, what would you tell me? It is 2. But why did you not tell me negative 2? Isn't a negative 2 times negative 2 also a 4? Yes. So when you square root both sides, there's two possible answers.
Oh, it's that plus and negative 2.
Yeah, it fell out. So this answer finally becomes y equals to, and I don't need plus or minus on both sides because it's kind of silly. So I just only use y equals plus or minus the square root of 20. No, you can't square root it. It's being connected. You got to go 25 minus x squared. It has to stay that way. That was a pretty tough problem. Okay, I'll take a breather.
Go faster.
No,
I need to go fast enough.
I could go fast, but I'd be the only one at the finish line. Yeah. I want to take as many of you with me on the trip as I can. Can we call it quits for today? It's Friday. Because we finished, this was the other day. Now we're going to continue on. We're changing these equations from being implicit to, you what? Were you here? Okay, let me pause this. For those that just came in or just got your packet, please find where we are at. Are we on the first page of notes, second page, or the third page of notes? The what? I think it's probably the third, but I could be wrong. Definitely says explicit and implicit on the left-hand side. And we talked about that third page. That's what I was thinking. I know I didn't finish where I was supposed to finish up. That wasn't your fault. It's my fault. Implicit functions have the x's and y's or the a's and the b's, if that's what you have in there, all mixed together. Okay? Did I say explicit or implicit? I have to rewind and see. Implicit is they're all mixed up. If I didn't say that, I apologize. Explicit is like something's on the outside. It's exterior. So you're solving for x, or you're solving for y, or you're solving for r. Okay? But when everything's mixed together, for instance, like when we did number 1, that was just a linear equation. But it was standard form. You had this in Algebra 1, standard form of a line. You notice you have a 1, invisible 1 next to the x, and you have a -4 next to the y, but it's not solved for y. So you have to do all that algebra to eventually solve this for y. That makes it explicit. Most of us are more comfortable with explicit than implicit. That's why a lot of your algebra books said, solve all your equations for y. It actually was pretty good for the graphing calculator. If you solve for y, then you can type it in the calculator. But FYI, not every equation can be solved for y. Sometimes you can never get y out of the mess. And I think we might, I don't know if this will have one. Number 2 was an equation for a circle. And I was able to solve for y, but I had this weird y squared on the left side. So I took the square root of both sides, and that's why I had y is equal to plus or minus, because whenever you square root both sides, you have two possible answers. You've seen that before. You've seen it with the quadratic formula that you had to submit. You always had minus b, plus or minus, the square root. Well, that told me something. That told me that when I created that equation, I must have had to square root both sides. So that's the explicit equation. All right. If you can handle those two, that's pretty much the hardest you'll ever have for the most part. But there's always harder ones, that we'll try to do. This one is interesting because the y right here is inside parentheses. Do you need the light off before I move on? I just noticed that sometimes you can't see it as well. Anybody need the lights off? Is that you? Would you be kind enough to turn off the lights? He's like, wait, I just got here, man. Don't bother me. Do you need a bolt out? Hit one and see how. Want another one off?
Sure.
All right. Can you see? I gotta see if I can find a couple cheap floor lamps. I wasn't picking on him. He just was closer than I was. All right. So you'll notice that the y is stuck in parentheses. So it's kind of like stuck in jail, and he can't get out. So I have to start removing things to see if I can get those parentheses removed. So the only thing I can see that I could do to both sides is probably, most of you say, move the x to the other side. Well, that only moves if you do the opposite of x, which is subtract x, subtract x. Now, this is a 3 minus x, because they don't go together. They're not like terms. So I'm left with y plus 1, still in parentheses squared, now equal to 3 minus the x.
Wouldn't it be 3 plus x?
It is. I don't know why I didn't see that a second ago. There she is. Let me get the door again. This time I'll get up. You did it last time. Thanks. Were you here the day before last? Friday, I guess? Probably not. And where we're at now. We're in, did that page, and note that page, and around the third page. I'll be posting this online, you'll be able to get all the notes. All right. Let me get tangled up. So I'm stuck with y plus 1 all squared equals to 3 plus x. And I almost made a mistake thanks to that individual back there. I can't remember all the names yet. So I want to get the y plus 1 out of jail. So you have to do the opposite of square to get rid of the square. When I say opposite, I mean inverse, really. So how do you get rid of a square? Square root. Very good. I'm glad there are people much smarter than me. I didn't keep the pen. Square root, wrong color, wrong thing. Square root, both sides. But when you square root both sides, you're going to end up plussing and minusing this over here. I mean, technically it's plus or minus on both sides, but I don't need to put it on the left. Okay, I can keep that just as a positive. And that does cancel out squaring, so that still leaves me the y plus the 1. Well, the good news is I finally got rid of the jail. In one more step, you'll have the answer. I need to get rid of the plus 1. I do that by subtracting 1. I have to subtract 1 from the right as well, but it doesn't go into the square root. That cancels. So I'm left with, there's a couple of ways of writing this problem. Most people like to move that minus 1 to the front. You don't have to. Y is equal, I will though, negative 1 plus or minus square root of 3 plus x. Now, if you were a rebel and you didn't want to do it my way and you wrote y equals the square root of 3 plus x minus 1, that would also be appropriate. But I've still got to do the plus or minus though. It just seems more complicated to look at that. And a lot of people tend to like to look at that instead. Yes? Yes. Number 4. Okay, so I see how they're getting harder as we go. Probably so do you. Let me turn this around. That would make it better for me. Do you see there's a cube root in the problem? The passages are up there on the thing. So I got a 7 on the right-hand side, and I can't really get the y by itself right away because it's being cube rooted right here. It's being cube rooted. So leave that alone for a minute. Get rid of the 1/2 x. How would I get rid of it? Yeah, I have to subtract it. Just try to stay with me and try to stay one step ahead. That way you can answer the questions. Because if you do that, just copying this down is not really learning. Oh, sure, you'll have a good set of notes, but you won't know what it means because you didn't put any thought to it. You still have to put thinking behind it and at least say to yourself, yes, I get that. That makes sense now. Okay, keep going. And, you know, as soon as it doesn't make sense, you should really stop me. I am here for everybody. I'm not here just for the person who's smarter than me all the time. I always have them in every class. There are people that pick this stuff up. That wasn't me in school. I don't know if I told you, I failed Algebra 1. I mean, I was failing it. I think the teacher had pity and I got a passing grade. But I didn't learn a thing. I was like lost every single day. I did try asking questions, but the teacher would just say, go back to your seat and I already gave you an example. Wow, thank you, sir. Thanks for the extra help. But in those days, they didn't have to do extra help. So let me subtract. I heard someone tell me subtract the 1/2 x from that. Not the 1/2 x. What am I doing? Yes, that's what I want to do. That's what I want to do. I got confused for a minute. So 1/2 x minus 1/2 x goes away. And lo and behold, I still have a negative of the cube root of y, now equal to 7 minus 1/2 x. Starting to make some sense now. So I have to undo what's being done with the letter y, and there's a minus in front. This minus stands for a -1 times this. It's a -1 times this. What's the inverse of timesing by a -1? The inverse of times, multiply, is always divide, right? So I will divide both sides by a -1. So when I do that, that negative does cancel. It did leave me this cube root of y. Now the other side gets a little complicated because when you divide the whole thing by a -1, that's the same thing as saying equals to a 7 divided by a -1, a minus 1/2 divided by a -1. You have to treat it to both of those pieces. So what happens is the 7 becomes negative, and the -1/2 x becomes a positive 1/2 x. And it's okay to leave that the way it is. Some people like to switch it around to put the -7 afterwards. But it doesn't matter. It's not important. It's not, I mean, if you wanted to write a 1/2 x minus 7 over there, you could write that. It's the same thing. I'm going to leave it because I'm lazy. One more step and I'll have the answer. I just have to undo cube root. Think for a minute. What's the inverse? Oh, let me ask you this question. What's the inverse of square root? Squaring. So what do you think and we do that a lot. So I think most of you say, oh yeah, we get that. The inverse of square root was squaring. The inverse of squaring is square root. Fine. So what do you think the inverse of cube root is? Cubing. So I cube both sides. When you cube a cube root, out will pop out the y. So there's my answer. Y is equal to in parentheses, -7 plus 1/2 x all cubed. When you cube both sides, you don't do plus or minus. When you cube root both sides, you don't do plus or minus. Only when you're square rooting because that 2 is even, or if you were doing the 4th root, you would do a plus or minus, or a 6th root. Whenever they're in even powers, and I know that's not going to stick in your brain, but when it comes up, we'll talk about it again. Questions on this problem? This problem had some heavier things. Yes. Wait till that person comes back, and you don't have to ask again. Just go, okay? All right, let's do 5. The y value is stuck in jail again. So let's see if we can get it out. Get rid of everything that is outside of that square root. Well, I have an x right here. Right here's an x. So if I subtract an x from here, it will go away. But I have to subtract an x over here as well. I think this one's easier than the last problem, because now I'm stuck with a negative square root of y plus 1 is equal to 8 minus the x. I mean, don't get me wrong, we still got to get rid of that negative. But we talked about that in the last problem, that I just divide both sides by a negative 1. And that will cancel that out, leaving my square root of y plus 1. And on the other side, I'm going to do a magic trick. See if you see what I just did. I'm going to write it as an x minus 8. What did I just do? I switched them. Because, I mean, I told you in the other problem, a lot of people like to put your minus number behind the x's. So the 8 became a negative 8. The negative x became a plus x. I just chose to switch them around to make it look kind of more pretty. I know that's an opinion. You may not think that it looks any prettier than if I had left this alone right here. That doesn't look ugly. It's okay. My next step is to get rid of square root. So the inverse of square root, I just asked you that a few minutes ago. Squaring. So you would be forced to square both sides. I'm just squaring, so I don't have to do plus or minus. It's only when I square root both sides. Square it. And that's just an x minus 8 times an x minus 8. We could do the math and call it x squared minus 16x plus 64. But I won't. But I will get rid of that square root, y plus 1. That's what pops out right here. And I'm going to leave this alone as an x minus 8 all squared. Yes, I could FOIL it out, write it down twice, do the first outer, inner, last. But I don't have to. Don't do extra work. But I do have one more step. I must get rid of the plus 1. Minus 1 will do the job. But then I have to do a minus 1 here too, which cannot go into the parentheses. So that leaves me the answer is y equals to, now I could switch them around, but I'm not going to. I'm just going to read x minus 8 squared minus 1. That would be an appropriate answer. If now's a good time to ask a question. And you guys, this stuff is hard stuff, you know. This is like most of you, it's your last math class unless you're, I would encourage you to move on to calculus. I am going to be teaching you everything you need to be successful in calculus. You won't have to be afraid of calculus. Everything I teach you is used in calculus. People say, is calculus hard? And the answer really is, what makes it hard is that it really thinks you know everything from the past. But every good teacher, if you have a good teacher, we still review this stuff. We'll review it really quickly, though. Number 6. You notice how the x and the y are being multiplied together? So there's a lot, and then I got another y here. That's pretty sad. I have 2 terms with y's. And I'm glad I don't have any y's over here. I don't have any y's over here, thank goodness. Nothing on this side. So now that they're all on one side, it actually isn't so bad. Now, if you wanted to, you could get rid of the minus 1 right away, because the minus 1 has nothing to do with the y's. So I will add 1 to both sides. And you didn't have to do that first. There's another first step you could have done. But I kind of like to get everything away from anything with y's in it. So that canceled out. So I'm still stuck with the xy minus 5y equals to the 2x plus a 1. Now that I have two terms with y, don't sweat it, guys. The way to get the y out of two terms is to do something you've done before. You've done it before. You just didn't know what you were doing. I factor out the letter y. I factor it out. In other words, I take each of these terms and I divide by y. So think about xy. If you divide by y, you're stuck with the letter x, because y times x is the same thing as xy or yx. If I take the y out of the 5y, take the y out, I'm still left with a negative 5. And think about the distributive property. If you were to go back to distributive property, it would come back to this. That's how you know you're right. If you were to distribute it back in, you would end up getting this original piece. All right? So I still have my equals to 2x plus 1. And you could have done that step from the very beginning. I could have done it from here if I wanted to have. I chose not to. I chose to get rid of the minus 1. So now I got to get rid of the x minus 5. And the x minus 5 is stuck together. You may not think this is easy, but it actually is pretty easy, because I can get rid of that whole thing by dividing by the x minus 5. Divide by x minus 5. And yes, it's all together. If I have a big fraction bar, that implies that it's together. If I want to put it in parentheses, I can, but you don't have to. It cancels. That whole parenthesis cancels that whole sets of parentheses. So I'm done. Y is equal to 2x plus 1 all over x minus 5. You don't have to put the parentheses if you don't want. If you wanted to put both of those in parentheses, you could. Was that super hard? So I can't tell with the lights off. I can't see your facial expressions. I don't even know if you're sticking your tongue out at me or anything. I can't see. I just have to have a little bit of faith if you're on the triplet. All right, that was it for those. So what were they wanting me to do now? Explicit functions are frequently written using functional notation. I think what he means is this. If the equation, explicit, if y, I'm making this up, y equals to the square root of x squared minus 1. That's definitely an equation. And it is explicit. It's solved for y. This is baby stuff. You know this. I could have written that as f of x equals to the square root of x squared minus the 1. That's the same thing. If it's implicit, I think I know what he's saying. If it's implicit, you can't write it in functional notation. Because functional notation would have to have an f of x equals something or an f of y equals to something. You don't always have to have f of x. F of x implies that this is actually y. F of y would imply the equation is x equals. In case you solved it for x instead. So what are we doing here? Oh, this is probably one of the last lessons you did earlier this year on Canvas. Evaluate means basically to take f of a negative 5, meaning the x is equal to a negative 5. That's what this means. Your x is equal to a negative 5. F of something. If f of something is f of x, that means this x is a negative 5. So I'll write it out like this. F of a negative 5 is equal to, since it's negative, you need to pay attention. People get these problems wrong all the time because they don't treat the negatives with care. You need to treat them special because you don't want to lose negatives. So this is the x being squared. In your calculator, you need to make sure that if you're using a calculator, that the calculator understands that all of this is being squared. Because you and I both know if I just say negative 5 squared, that doesn't mean that the answer is going to be positive. Because we know that a negative 5 times a negative 5 is positive 25. But if you do it this way, that's going to become a negative 25. And that is not what we want. So let me get rid of the evidence here. I want the whole thing being squared minus the 6 parenthesis of a negative 5 again. That way I'm not losing it. If you forget to put the parentheses, you might do this. Don't write this part down. Negative 6 minus 5. What do you think most people think that means, negative 6 minus 5? It means you're subtracting negative 11. We don't want that. So you need to be careful not to mistake that negative 5 to be subtraction, but a multiplication. And then I still have my plus 23. So I come back to the left. Remember we were doing, I don't remember if it was you guys or another class. We were doing some order of operations and stuff. Negative 5 squared, as I said, was a positive 25. A negative 6 times a negative 5, I hope you all know, is a positive 30 added to 23. So I got a positive number, positive number, positive number. You're just going to add them up. I'm too old to do that math. Could someone please add those up for me? Bless you. Anybody? If not even one person, 23? Yeah, I just brought down the 23 here and here. 78, I'm going to take your word for it unless somebody else says we're wrong. This is sort of how I know we're on the same page. When there's an easy problem to do, that people are on the same problem, they're keeping up with me. I don't think I've gone too fast, but I'm not you. I can't be the judge. You have to tell me. I am here not to do 1,000 million things in a day. I'm here to do a few things well. So it's your job to make me accountable to it. Basically, I work for you. You're my employer. I'm here to serve you, to assist you. Moving on. H of x is 7 minus x squared, and the h can be a perfectly functional letter. F of x, g of x, h of x, k of x, doesn't really matter. He chose to name this function h. He's plugging in the 9. So h of 9 will look like 7 minus 9 squared. All right. I really need to hear the whole class give me this answer because I don't think this is that bad. So I'm going to pause for a minute. Matter, I'll even pause my recording while I count down. On? Let me hear the class answer. Say it again. Louder. No, I'm not getting anybody. Who thinks they know the answer? Should be everybody. I just heard the answer. Loud. 88. Is it 88? Anybody agree with 88? I can see where 88 came from. Anybody have something else? Now everybody's afraid to say because they already have a different answer. Who disagrees? What do you have? A 74? Positive 74 or negative 74? I hear both.
I'm talking about the 7 right there, the positive, taking away, so we're doing the negative.
All right, well, let me see what I have. I'll keep the 7 because order of operations say I should go left to right and do the exponents first. 9 squared is? 9 squared is 81. Now it's 7 minus 81. I know what maybe somebody did. I think somebody in here took the minus 9 and squared the whole thing. But that minus is not being squared. I don't see a parenthesis around that minus. That minus, the only thing being squared is the x. So it's technically a positive 7, and you're adding it to a negative 81. The answer should be negative. And I believe the answer should be the negative 74. So how many of you thought it was that to begin with, but were afraid? Several of you. It happens. Don't be afraid to be different. All right? 2a plus, whoop, what happened there? Beginning of this assignment. Then there was this page. And if you didn't do any of it, well, there you go. You can get it all done. And the last page. Actually, that's on Tuesday, okay? Well, next page. This is the 4th page of notes. Obviously, they're getting harder. Now, the question is, do I need to work them all with you right now? I'll do another set, and then I'm going to want you to work with somebody to finish up a few of the answers. So let's see here. Function is p, plugging in a positive 4. So p of 4 would look like this. Everywhere I see an x, I put a 4. 4 plus the 1 over 2, and there's a 4 with that x, that x right here. So I'm going to put that in a parenthesis so I can keep it separate from the 2 and then square it. Plus a 4 times the 4, I put it in parentheses, minus the 13. So now it's just a matter of doing left to right. I would probably do the whole numerator first right now. May as well do that. In other words, do the numerator first, and then worry about the denominator one step at a time. Some of you are going to be so good after you practice 20 of these, you probably could do that step. You could probably do all of that. You could probably do that. And then you could probably do less steps than I'm going to do. And that's okay, as long as you group it in the right way, that the order of operations will still give you the same answer. So I'm going to go, like I said, I'm going to do the 4 plus 1 is a 5. Oop, wrong pen. 5 over. I'll keep it simple for those of us who are not proficient 100% yet. The 4 squared is a 16, so that turns into a 2. you can use a dot to also multiply. 16 plus a 4 times 4 is also 16 minus the 13. So now when I think about what's happening, my next step, I'm going to still keep the 5 on top, but then I have a 2 times 16 is a 32. Then I have a plus 16 minus 13. I'm just going to write it out. Plus 16 minus 13. So now I keep the 5. Maybe you're good enough to do all the addition and subtracting, but I'm going to do the addition. What's 32 plus 16? I'm going to do, wow, he's fast. How much was this? 48. 48 minus 7.
13.
48 minus 7 is 13.
No, the number was
48.
Oh, it's a 13? Can't read my handwriting? 13? Oh, jeez. Minus 13. How much is that one? 5 over 35. How would you leave the answer? Perfect. 1 over 7. I would always caution myself to do an extra step here and there so I don't get lost. Especially, what if I get it wrong? I want to be able to go back and find where I did something wrong. Making a mistake is not a bad thing to do. It's just an opportunity to learn something that I neglected or something. Questions on that one? Okay, wouldn't you know it, he's getting longer. But this looks better than having a fraction. I don't know about you. I'd rather do this one than the last one. I saw the last one and I go, oh, yuck. But anyway, I need to be, not prejudiced against fractions. They're almost people too. G of, nobody else heard it, don't worry. G of a negative 2 is, I can probably say anything and most people are like, whatever, I can tell you're smart. Negative 2 cubed. I always think when I go home, whoever laughed at my jokes, they were actually smart people. Because some of my jokes don't make sense unless you really think it's so crazy or outlandish. Plus 3 parenthesis the negative 2, and it's good to keep it in parentheses. That whole negative 2 is being squared. Plus 7 times the x, that means times a negative 2 minus a 4. Do I really think this is really pre-cal work? Do you think I think it's pre-cal? No, it's really not. But this first unit was really supposed to be about remembering your number facts, your number operations, your order of operations, terminology. So there's kind of hit and miss of some stuff that you knew very well, but I'm sure you didn't practice a lot of these like this. So I think some of these problems are higher level than you had to do before. And I'm not ashamed of it that we're working hard on it. Negative 2 squared going left to right. Ask yourself, will it be a 4 or a negative 4? Oh, who said that? Her back there? You might want to make a note on that paper because on test time, if you still have that paper, which you should, and I see it or you show it to me, I'll give you some points. Actually, the other gentleman too who caught me, if you go back to that problem and make a note, please keep me honest. It's a 3. It's not a squared. It was just the way I wrote it. All right. Who agrees the answer will be negative whatever? Thank you. Negative times a negative must be negative. So the answer is negative something. Negative what? Negative 3? 8, yes. Plus, all right, here's the negative 2 being squared. That's a 3 times what? 4. It had to be a positive number. Then I have a 7 times a negative 2, negative 14, bring down the negative 4. I'm resisting the temptation to do more than one step because I want to make sure that I take everybody with me on this trip. So I know you're going to say that's ridiculous. Why waste this whole line of work to write everything down? Negative 8 plus the 12 minus the 14 minus the 4. You see what I did? I wasted a whole line to put one little step that some of you could have done it in your head, I know. But just because. Now, negative 8 plus 12 is what I do first. Left to right. It's positive, right? Because I have more positives, so it's 4. I am bringing down the negative 14 plus 4 only because I'm sticking true to what I'm saying. Now I do the 4 minus the 14. Negative 10 plus the 4. Now I do the negative 10 plus the 4. Negative 6. It's what?
It's minus 4.
It is? But nobody said nothing when I wrote a plus. I am so hurt that nobody saw it. I would love to lie to you and say, I did it on purpose. So what it becomes? Not a negative 6, it's a negative, how much? 14. You know, the bad thing about these problems, you can be smarter than Albert Einstein and still make mistakes on these. Because Albert Einstein actually did make a lot of mistakes when it came to just basic computation. He even made a quote. He said that if you think you have problems, I assure you I've had more. Yep, so I'm in good company with Albert Einstein. Q of x, I'm doing Q of a negative 15. It's a simple plug and chug this time because I have a 6 minus a 2 times the negative 15. That's all it is. Looks very simplistic, but I will do one step. I'm sure if you read my mind, you know the one step I'm going to do is probably this right here. If you read my mind. So I'm still going to keep the square root. I'm going to keep the 6. But what does that shaded yellow become? You don't see yellow up there very dark.
30.
Yeah, it is positive 30 because they're both negative. Plus 30. Square root of 36 is how much? 6. That wasn't that bad. I've had worse. This might be worse because some of you forgot what these two lines mean. How far? Wow, not only did he said the definition as well. How far is the number from 0? So it can never be negative because it's just a plain distance. Whether you say how far I am from Raymondville versus how far I am from Brownsville, it's going to be a positive number. It's going to be 21 miles to Raymondville from here, and Brownsville probably roughly 24. But one's north and one is south. We don't care. We don't say, oh, Raymondville is 21 miles north. Nobody says that. Not when they ask you, how far is Raymondville? They don't care what direction it is. Now, if they say, which way do I go? That's different, all right? So I'm going to plug everything in. P of a negative 10 should look like the absolute value on the left side here. 1/2, or is it a negative half? I can't tell. I wrote on it. Negative?
No, it's just
1/2 times the negative 10 minus the 14, and I close it off. Does that look about right? What do you think the hard part in there is? Yeah, some people don't know how to handle that. And it's a what? Yeah, you can read it left or right. What's half of a negative 10? Or you could even say 1 times a negative 10 is a negative 10, and 2 times 1 is 2. A negative 10 divided by 2 is still the same answer, right? You can read that a lot of ways. So absolute value of negative 5 is what I'm hearing. Then I have this minus the 14. What's a negative 5 minus 14? Absolute value of a negative 19 is, how far is negative 19 from 0? Just plain 19. Whoop, I didn't have that symbol. So can you see how the author is just reviewing some notation with you? Because you're only human, you know, most of us are. This is different. We literally have the x as our exponent. That's called an exponential function. That's another chapter, but still, you've used it before. F of 4 is 5. Oh, this time he put the dot in front just to show you times, but he didn't have to. He could have just left it as a parenthesis by itself, but I kind of respect him for doing that to show it to you like I showed you earlier. And that's a negative 3 now to the 4th power. So what do you think the first step I'm going to do? Would I want to do the 5 times a negative 3? I think that's why he put a dot, so you wouldn't accidentally do this multiplying first. You have to do this part first. So you got a negative 3 to the 4th power. Will that end up being positive or negative? Well, why?
Because if it was an odd number, it'd be negative.
That is the smartest thing I've heard today. Yeah. Yeah, you think about how many negatives are being multiplied. Negative 3, I don't know if you can see what I'm writing up there because it's way too high. Negative 3 times negative 3 times negative 3 times negative 3. These two cancel out. These two cancel out. So you're losing them all. So with that being said, that turns into 5 times how much? 81. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Yes, sir.
Didn't you just do 2 of them and then multiply?
You could have done the 2. And that what he's saying is negative 3 times negative 3 is a 9. Negative 3 times a negative 3 is a 9. 9 times 9 is still 81. Yeah, works that way just as well. 5 times 81, who could do that in their head? What? 405. I don't know how he did it so fast. I was thinking 5 times 1 is a 5. 5 times 8 is 40. That's what I was thinking. That was a lot. He did it faster than me. Where are we at? Okay, he's introducing using the cube root. A of 17 is, there's a negative. There's my cube root with my little 3 in the index there. That's a 2 times the 17 minus the 7. What steps do you think I do first?
Do the +1 after.
Oh, I didn't see the +1. Thank you. I would have really messed that one up. That +1 is outside of the square root. So what do you think I'm going to do first? Yeah, you got to go in there and do that multiplication. So you're still stuck with the negative. You're still stuck with the cube root. And so the 2 times 17, 34. Then I have to, in a minute, subtract 7 from it. When I get done, I'll do the cube root of it. Then I'll add 1 to it. Okay. I want that word. Erase. Be my friend. Be my friend. Erase it. It doesn't. There it goes. Finally. Okay, equals to, equals, pen doesn't want to work. Equals, negative still there. Cube root of what? 24 minus 7.
That's 34.
Oh, it's 34? 34 minus 7. That's why somebody said 29. But would that be right, though? 27?
And then plus 128.
Yeah, it is 27. Then no, that plus one's outside. You got to do the cube root first. Negatives. So you got to think, what times what could be 27? The same number. 1 times 1 times 1 is a 1. 2 times 2 times 2 is an 8. 3 times 3 times 3 is a 27, right? 3 times 3 is 9, times 3 is 27. So that's a negative 3 plus the 1. Final answer? Negative 2. You mean we got to memorize perfect squares and perfect cubes? No, you don't have to. God made us a calculator, but the more you can have in your head, the less you have to pick up that I can. Any questions there?
Yeah, I think he's less than how you got rid of that square root.
How I got, when you have a cube root of a number, you have to ask yourself, what number multiplied by itself the 3 times gives you 27? Yes. So 1 times 1 times 1, I said, the cube root of 1 would be 1. And 2 times 2 times 2 is 8, so the cube root of 8 is a 2. 3 times 3 times 3 is 27, so the cube root of 27 is a 3. So this became a 3, but that minus came from the outside of it. Okay, 15. It's a weird equation. It's just a polynomial. Can you what?
Go to the buses for some.
Oh yeah, I forgot about you do that. All right, so you want to try to, wait, before you go, your homework is, so let's do 15. Oh, it's the ugliest one we've had. What time's the bell ring?
45.
Really? Well, you got,
I found this on the web.
well, that is so nice. I wasn't even looking for that. You see, she reads your mind. She knows what you want before you even, no, I didn't want that, no. I don't know what that was. I thought she was like helping me out. I don't think either, I did enough of those already. Okay, you may have heard that I had to pause, didn't finish in 1A the whole thing. So let me finish it up here. That way everybody will have the full lecture notes. Okay. Get that adjusted right. We are going to do another functional evaluation. This time, I'll be plugging in 3y squared in place of the x. So that's what's happening. So f of 3y squared would become a 3y squared, all of it, raised to this third power, plus an x, back up. The x is actually going to be a 3y squared to the second power. So what we have are powers to powers. If you look at it the way I'm seeing it, power to a power. And technically, there's actually a first degree power there as well as here. So I still have a power to a power. I still have power to a power. I still have power to a power. And the rule for exponents, I hope you remember, is that a power to a power, you're supposed to multiply those two numbers. You keep the base, you multiply the 1 times the 3, that gives you 3. Then the y, new base, keep the base, multiply the 2, now times the 3, that's a 6. I don't need the parentheses any longer since I broke it all down. Added to. 3 to the first to the second is 3 second. And then y to the second would be the fourth. Now, you might want to go a little step further because 3 to the third is 3 times 3 times 3, which is 9 times 3, which is 27. So I'll go 27 y to the 6. Then 3 squared is 3 times 3, which is just a 9. So plus 9 y to the fourth. Please do not assume you can combine those any more than they are. That's probably the answer I would take. I do remember back a long time ago where every college professor insisted that you factor everything into factors. So if you were to be a nerd, you would say, well, what goes into 27 and a 9? The only number I can think of is a 9. 9 goes into 9. Always take the largest. You could have said a 3, but then you do another 3 later. So you could pull out a 9. So I'm showing you an alternative answer. Pull out a 9, and then you have y times y times y times y, and here you have y times y times y times y times y. So there's 4 of them that they both have. So I can pull out y to the 4. That leaves 9 times what is 27, a 3. Y to the fourth times what is y to the 6. Well, you're missing 2, so it's y to the second. Plus, you already pulled out the 9, so there's an invisible 1. And you already pulled out the y to the fourth. So the whole thing is just a 1. That would also be an alternative answer. But I'm not going to. That would be like for someone who has nothing else to do on a Friday night. Let's do 16. Doesn't look too bad, but you are still taking a quantity here. I mean, it's got a number and a variable c. So that has to be plugged into the x twice. So when I do g of a negative 5c, that turns into an, just checking something here, 8 times negative 5c. Remember what I said about keeping your negatives, keep them safe and sound? I put them in a parenthesis. Minus a 10, so I don't actually do a wrong operation. All over, all of negative 5c. Now, since I'm not multiplying by it, if you just put negative 5c, it would be okay. If you want to put the parenthesis, you can. But in this case, it really doesn't change anything. So, if I have your permission, I'm just going to leave it like that. Doesn't mean I'm done by all means. So this requires me to multiply. So that becomes equals to a negative 40, still times the c, minus the 10. That's the numerator, all done. And the denominator, negative 5c plus a 5. That is a pretty good answer for what I'm considering full credit. But I can tell you right now that even if I take that answer, if I read off the answer key or give you the answer key, there's probably a good chance that since the 40 and the 10 and the 5 and the 5 each have a 5 in it, it would be the same thing. This is an alternative answer, is equal to, if I pull out a 5, just even if I want to get rid of these negatives, pull out a negative 5 from the top, that would give me a positive 8c. And then a minus 10, pull out a negative 5, would be a plus 2, because 2 times a negative 5 is a negative 10. But I'm just going to leave it, let me take that off, all over. And you're going to see why I did this. The bottom, pull out another -5. And then if I pull out a -5 out of a -5c, obviously I'm left with just a c. And if I pull out a -5 out of a 5, that sign has to change because you're pulling out a negative. Negative times a negative is the positive. So that becomes -1. And I kind of like this because I can now just divide both by a -5 over a -5. So another alternative answer could be just this, whatever you see here. You want to go further, you could factor out a 2 out of the top, leaving a 4c plus a 1. The bottom doesn't change. C minus 1. That's also a very good answer. It just goes to show that you could always do more, you know. And I know we're not really always that motivated. I know I'm not. All right, 17. That's a quadratic. Can you see the second degree? That's a first degree. It's a parabola. It's +1 here. It opens up. I'm just saying, just to let you know, for those that are actually thinking as I talk, I want to plug in 2a plus 7. And so all of this has to go here and here. This is going to take a few more seconds here. So h, better write smaller, h of a 2a plus 7 will be that x, all of it, 2a plus 7, all squared, minus the x, 2a plus 7 minus the 1. Well, technically, that's the answer. I mean, it's all plugged in, nice and pretty. But I know for a fact it's not simplified. So you probably should try to simplify it. And realizing for a minute here that 2a plus 7 squared does mean 2a plus 7 times 2a plus 7 means you're foiling two binomials. And you've done that before. So that turns into first times first, FOIL, that's your first times first, 4a squared. Outer, 2a times 7, that's a 14a. That's the outer. Then the inside, that's an inside, is another 2a times 7. Well, there is a little trick that if you saw that as a binomial being squared, you always knew it was going to be a 2a times 7 and you're going to double it. Because there's a 14 and a 14 that doubles it. Moving on. 7 times 7 is the last two terms. Last. That's a 49. Now, this negative in front causes me to distribute that negative, meaning the signs change. Minus 2a, minus 7. And the minus 1, who's not bothering anybody, just comes down. So you can see you have a lot of room for combining like terms. There is only 1a squared, so I bring that down 4a squared. You end up having two of these terms, which is 14a plus 14a. And I did tell you, you're going to have these two multiplied together, and you're going to double it, plus 28a. Oh. I'm going to leave that for right now, 28a. Plus the 49. The 49 goes with the -7 and the -1. And you're going to see what's going to happen. 49 minus 7 is a 42. 42 minus 1 is a 41. And I didn't see this minus 2a. Well, if I would have seen it, I would have combined it with this one right here. So the final answer that is the best answer, 4a squared, 28 minus 2 is 26a plus a 41, assuming I'm right. I make mistakes all the time. All right, please make this easy. And it's not, because now I got an m minus 1, and it's going to be cubed. Well, thank you for nothing. K of m minus 1 will be 4 times m minus 1 cubed plus 7. I'm lazy just like you. I would love to say, I'm done. That looks good. And it technically is the correct answer, but it's not simplified because I really needed to do the m minus 1 times m minus 1 times m minus 1. Well, I can do these two really fast. That's going to be an m squared minus 2m, because remember what I told you? If it's the same thing, you just multiply that together and double it. Then minus 1 plus 1. All of that has to be multiplied by another m minus 1. So that's going to take the time. And don't forget, I'm still going to say that's all equal to that plus the 7. Watch me forget the plus the 7. I'm probably going to forget the plus the 7. That's just like me. Okay, there's 3 terms, 2 terms. I'm going to create 6 terms, 3 times 2. Some of them will combine. M squared times m is m cubed. M squared times a negative 1 is a negative m squared. Negative 2m times m is a negative 2m squared. Now, if I'm going too fast, the advantage of watching the video, you can always pause it. You can always rewind it. Negative 2m squared. And negative 2m times a negative 1 becomes a plus because there's 2 negatives. Plus 2m squared. Okay. Only got 2 to go. 1 times m, you're right, is m. 1 times a negative 1 is negative 1. And so my answer equals to all of that. Let's not forget the plus 7 out here. Okay, here goes. How many m cubes do I have? I only have 1 term. So you know it's going to be m cubed. I have a negative 2m squared. I have a, did I do this right? Plus 2m squared? Guess, I hope I did. If I'm not, I'll give you extra credit if you tell me. That goes to 0. Wow, I wasn't expecting that. I hope it's right. Let's see, I'm curious. Negative 2m, then I did, that was in the second one, so. Where am I getting it? Oh, right here. Negative 2m squared minus, still trying to figure where I get it. I'm looking, I'm still looking. M squared minus 2m plus 1. M squared m cubed. Negative 2m, that's negative 2m squared. Negative 2m. I bet you I messed up. I'm going to have to do it again. M squared minus 1 squared. Because it was a minus 2m squared minus plus 2m. Yeah, it's just a plus 2m. It's not a squared. That one is gone. Okay, I caught my mistake without finishing it. M squared, then the minus m squared, this one, minus 2m squared gives me a minus 3m squared. That looks better. And then a 2m plus an m gives me a plus 3m's. That looks a lot better. I'm not going to give you the secret. Oh, and then minus 1 plus a 7 is a plus 6. There's my answer. I was expecting a 1 coefficient, a 3 coefficient, and another 1 coefficient in front. So it works. I think that one's right. If I'm still wrong, I owe you. Now, the last 4. Hopefully they're not as bad as those last 2. Using the graph to the left, find each function value. That's a piece of cake. Piece of cake. My friend Mr. Ortega calls it papitas. So function evaluated when x is 1. I go to x is 1 right here. Here's x is 1 right here. But you have to touch the function. So I'm going to trace all the way down. It's that point right there. That's the functional value. So the y value, this is the x value. It's a 1. The y value will be the answer. Down 1, down 2, down 3, down 4, down 5, down 6, down 7, down 8, down 9. That's down 9, negative 9. While I'm looking at 21, let me do f of 5. F of 5. Well, 5 is 1, 2, 3, 4, 5. There's the x of 5. That's the x of 5. The answer will be a y value. I have to go up. 1, 2, 3, 4. I think I got to go up a little more. I think it's there. I think it's a 5. Okay? That's not bad. Let's do the last two. F of a negative 2. Remember, that's my x value. My answer will be the y value. So I go to negative 2. That's 2 to the left. I'm going to make it a little bigger here so you can see it. 1, 2 to the left right here. And I think I got to go down 1 to get to that point. So the y value is a negative 1. And if you disagree with me, it's okay. I've been wrong before. Last one, f of 0. That's the x value. I'm looking for the y value. So I go 0. 0 is right here at the origin. I got to go all the way down. 1, 2, 2, 3, 4, 5, 6, 7, 8. I think it goes down to the 8. Down 8 would be a negative 8. Negative 8. So, there it is. For those that are watching the video, maybe I ended up at a different problem for your class. So I'm going to go all the way to the back. Was the one I just finished up right now. I can make that a little bigger. And that finishes those notes. And wrong page. Good to do. It takes us to
Last page.
4th page starts the homework.
So we do homework.
And I did say do all of that. I'm not going to look is all of this page and then same assignment. This first page in the homework assignment, make sure you put your whole heading on it. Do that whole first page. Those are just looking at pictures, looking at a graph, looking at the mapping, coming up with the domain and range like we had. The second, I wanted all of those done. You should have done those by now. The last page thing. The odds that, but I'm not going to, the following page is odds. Okay? Page, there's no sense at doing all of them. It's crazy. It's too much work. So the odds would be pretty much the right side. Okay? If you do them all, you get extra credit if you want to do extra. Also, bear in mind, you still have to do those Canvas things. And make sure that you've gotten the first, pretty sure he only said 6 lessons that he was counting for the progress report. But I'd get it all done because once I take over, I won't be really counting too much of Canvas stuff unless I make it. And I could put this on Canvas, no problem, so it's always there. But I think I'll call it quits if the bell's going to ring and you can get your stuff squared away. Homework, just the odds. If you want to do the evens, I'll give you extra credit. So let me go back to the beginning of this whole